Hi everyone! In this exercise, we will calculate post-flood pixels from Sentinel-1 SAR image, as we are working on the flood situation of the year 2022. So, for pre-processing, load the codes we got from previous exercise, which are about importing and filtering Sentinel-1 collection, like this. As we know, to calculate water extent on an area, we calculate NDWI, which gives value 1 to water bodies and 0 to other classes, like vegetation and urban area. And using mask function, we only get one value, that is water. So, now, as we only want to calculate the post-flood, so what about the permanent water area like rivers, lakes and small channels? They are not flooded water. If we apply NDWI on this SAR image, it will calculate every water body, regardless it is flood water or permanent water, which will disturb our analysis and give us false results. For this, we have to calculate the permanent water, and then we will calculate post-flooded water from it. Now, to calculate permanent water, you can use any satellite data, as we don't need any smoother surface scattering to calculate here. We will simply calculate NDWI from it and then apply masking to extract permanent water. I will go with Sentinel-2 harmonized data collection. In our previous modules, we used Sentinel-2 MSI. First, we will create a function to make our Sentinel-2 collection free from any cloud pixel by using cloud masking method. Filtering the cloud means that we create our script to choose the date that has the least cloud cover within a specific time range. We can establish the threshold of cloud cover that we want inside the code, and masking cloud is used with the multitemporal satellite. There are several methods to mask the cloud. The underlying concept of masking cloud is equalizing pixel value of cloud into 0. We will create a function by selecting QA60 band from the Sentinel-2 harmonized collections metadata, and then we will set both cirrus and dense clouds to bits less than 1. These are Sentinel-2 values for removing dense and cirrus clouds from the images. Now, mask the image using bitwise and equalize both clouds to 0. Return the image and add update mask by dividing it to 1000 to get accuracy like this. So, we have created a function called as mask S2 clouds. Now simply add Sentinel-2 harmonized collection from the datasets and filter it by date and cloud threshold value and apply cloud mask filter. Create visual parameters and composite using .mean and clip it to your study area. Hit run. Here we have a cloud-free permanent water Sentinel-2 image. Now, let's calculate NDWI to get only water pixels. To do it, simply create a new variable, add your Sentinel-2 filtered dataset with mean, and clip it to study area. Then calculate its NDWI using .normalize difference method. Define required bands, then define visual parameters. Here, you can see we have added a SRTM image. That is because sometimes SAR image also calculates the shadow pixels of ground objects, like hills. That is why we will add a threshold value to SRTM image to remove these pixels as well. Now, define a variable to update mask NDWI and add a greater than threshold with value 0. It means it will only show pixel with values greater than 0. In our case, it will be water. Similarly, update SRTM mask with less than or equal to threshold, having value 500. Add it to map and then hit run to get only permanent water pixels. Here, we have only water areas. Now, let us calculate the flooded water. For this, introduce a new variable, and select the band VH. Then apply a threshold on it with any negative value, because to calculate post-flood we assign negative values to the threshold, so that it can calculate pixels except permanent water bodies. Similarly, apply a threshold to SRTM image. Now update mask for flood variable with equal values of 1, and update mask to NDWI image with less than threshold to 0. It means it will only show pixels of flood water. Define visual parameters and add it to the map, then hit Run. Here you go, all the floodwater pixels. If you turn off the RGB image and turn on Clipped S1 image, you can match the flooded areas with it. As you guys can see, it was the extreme flood of 2022 by comparing these red pixels with permanent water, which is a great difference. That's all for today. Thanks for watching.